Hello and welcome to this short video on data protection with SnapCenter for SAP HANA on Azure NetApp Files. We put together a series of demo videos where we explain how SnapCenter can be used to optimize data protection operations of your SAP HANA landscape. This video is part 1 of the series, and we will focus on the data protection configuration of SAP HANA systems in SnapCenter. Before we jump into the demo, I want to briefly describe the environment that we are using for the demo. SnapCenter is a software provided by NetApp and needs to be installed either on a Windows or Linux host. Supported Linux distributions are SUSE Linux Enterprise Server and Red Hat Enterprise Linux. In our lab environment, we have set up an SAP HANA single host system Peer 1 using Azure NetApp Files for the data log and shared volumes. An Azure service principal needs to be prepared, which allows SnapCenter to execute snapshot backup, restore and cloning operations on the ANF volumes. The HANA plugin provides the HANA database specific logic and must be deployed on each HANA host. The HANA plugin communicates with the HANA database using the HANA HTTP SQL client and a user store key. In addition to the HANA system Peer 1, we also have set up a HANA system NB1 with enabled HANA system replication. Within the demo, we will first have a look at the ANF volume configuration for our demo system Peer 1. We will then create a HANA database user and user store key, which will be used by SnapCenter to access the HANA database. As a next step, we will make all required configuration within SnapCenter. First, we need to configure the credentials to access the ANF volumes using the Azure Service Principal and by selecting the corresponding NetApp account. Now we will look at the deployment of the HANA plugin and the auto-discovery process after the deployment is done. At this point in time, the HANA system is available in SnapCenter, and we need to configure the backup policy and the resource protection. And finally, we will briefly touch on the protection of volumes outside of the HANA database and the specifics when using HANA system replication. Now let's start with the Azure NetApp Files volume configuration for the HANA systems in our lab. The ANF volumes are configured according to best practices for HANA documented at the Azure website. There's nothing special to be considered when using SnapCenter as a data protection solution. We have used ANF application volume group to deploy the volumes for our HANA systems. We will use the HANA system Peer 1 to showcase the configuration steps. We will also look into the specific configuration of a HANA system with enabled HANA system replication. For the HANA system Peer 1, we have deployed a data, a log and a shared volume. These volumes are mounted at the HANA host using NFS. SnapCenter uses HTTP SQL and a user store key to trigger operations on the HANA database. HANA backup operations for the system and all tenant databases are executed at the system database. Therefore, the database user which should be used by SnapCenter must be created at the system database. The user requires specific privileges to trigger these backup operations. At the HANA database host, a user store key must be created using the database user that has been created before. This key must be created for the SID ADM user. As said, backup operations are executed with a system database. Therefore, the port must be configured accordingly. Now we are logging onto SnapCenter. The dashboard provides an overview of configured hosts, job activities and alerts. The resource screen lists all HANA systems which are configured in SnapCenter. We have the system Peer 1, which we will use for our demos. We also have two systems NB1, which are configured in a HANA system replication relationship. As mentioned before, SnapCenter requires credentials to execute snapshot backup operations on the ANF volumes of the HANA databases. You need to provide information about the Azure Service Principal, which must be prepared before. When the credentials are configured, you need to add one or more NetApp accounts which are used for the ANF volumes of your HANA systems. As a next step, HANA hosts must be added to SnapCenter. When adding a HANA host, the HANA plugin will be deployed on the host and phase 1 of the auto discovery process starts. In our lab setup, we already added the HANA hosts of our systems PR1 and NB1. To add a new host, you click on the Add button. You need to provide the operating system type, the host name, and credentials to be used to deploy the HANA plugin on the host. Now you need to select which plugin you want to deploy on the host. SnapCenter supports various database platforms as well as native file systems. Clicking on Submit would deploy the HANA plugin. In the SnapCenter resource view, a new entry with a logged item would appear after the plugin deployment. At this point in time, only host-level discovery has been executed. To discover the complete HANA resource, database credentials are required. When clicking on the logged resource, you will get asked for the HANA user store key to be used to connect to the database. Here you would provide the name of the key which has been configured before. Now SnapCenter would start the phase 2 auto discovery. When auto discovery phase 2 is finished, SnapCenter has discovered all relevant information on the database level. For our system PR1, we only have a single tenant. If there is more than one tenant, they would be listed here as well. Log backup and backup catalog locations are important for the recovery process. HANA system replication configuration is discovered as well. The relevant storage information is discovered as well by SnapCenter. For the system PR1, we have a single HANA data volume. For HANA system with multiple partitions, we would see multiple volumes listed here. All the above parameters could change. Therefore, SnapCenter is executing the auto discovery operation with each backup run and stores the information together with the snapshot backup information. Okay, now we have seen the operations and configuration steps to add a HANA system to SnapCenter, including auto discovery. As the next step, we need to configure backup operations. SnapCenter is using backup policies to define backup types, schedule types, and retention. These policies are typically not specific to a single HANA database, but are valid for multiple HANA systems. In our lab, we have configured two policies, one for snapshot backups and the second one for block integrity check operations. Let's first look at the snapshot backup policy. Since SnapCenter supports multiple storage platforms and Azure NetApp Files is managed differently than other ONTAP-based systems, we need to select Azure NetApp Files as a storage type. SnapCenter supports snapshot backups as well as file-based backups of HANA databases. File-based backups are used to run a block integrity check of the HANA database. For our policy, we select snapshot-based backups. Snapshot backup operations should be defined with the schedule type hourly, since it is recommended to run multiple snapshot backups per day. The schedule itself is configured within the resource protection configuration, which we will cover in a minute. The backup retention can either be defined based on a number of backups or time frame. In our example setup, we have configured 12 snapshot backups to be kept. For the block integrity check operation, we need to select file-based backup. The block integrity check should be executed on a weekly basis. The last configuration step is the setup of the resource protection. First, the snapshot naming convention is defined. It is highly recommended to add additional fields to the snapshot name to allow to identify the operation source. SnapCenter supports the execution of custom scripts at the various steps of the backup workflow. You can also provide specific parameters to those scripts. With the next screen, you can assign policies to the resource. In our example, we assign the local snapshot and the block integrity check operation to our resource PR1. For both assigned policies, we have configured a schedule. The snapshot backup is taken every 4 hours. The block integrity check is executed once per week. When the resource protection configuration is done, backups are executed based on assigned policies and schedules. In addition to the HANA data volume, other volumes which are part of the SAP landscape must be protected as well. Examples are the HANA shared volume, the volume for SAP application server binaries, or the transport directory. SnapCenter supports snapshot backup operations for these volumes as well. You need to select non-data volume in the resource view to get the list of configured volumes. In our lab setup, we have configured the shared volume of the HANA system Peer 1. Non-data volumes are not auto-discovered and need to be configured manually. This manual configuration mainly consists of selecting the ANF volume where the data is stored. Policy assignment and resource protection is done in the same way as for the HANA resource shown before. HANA systems configured with HANA System Replication have additional requirements for snapshot backup operations. Backup operations can only be triggered at the current primary system. Therefore, a snapshot backup should only be taken at the primary system volume. On the other hand, backup retention management, including the deletion of backups, must be done for both host snapshot, independent which host is currently the active one. In SnapCenter, HANA system replication hosts are configured in a resource group, which allows to manage backup operation for both hosts as a single entity. First, the HANA plugin must be deployed on each HSR host. The SnapCenter auto-discovery process identifies the HSR configuration and the current role, primary or secondary, of each host. Then the resource group is configured and protected in SnapCenter. The main difference to what we have already seen is the resource-to-resource group mapping, where you add the resources of the HSR-enabled HANA system. Backups are now executed based on policy and protection configurations. With that, thanks a lot for watching the video. Take care and bye bye.